What's going on, Rob Mob, coming at you with another video. Now here we're going to begin off our lesson 5 problems with one of these exit tickets that we had. This is our lesson 5 exit ticket. So very trivial problem, so let's go through it. Lynn rolls a 6-sided number cube and then chooses one card from a deck of 3 cards numbered 1 through 3. What is the probability that the number cube and the card have the same number? Now immediately there are some things you should notice about this problem. A number cube, 6 sides labeled 1 to 6, and then a deck of 3 cards numbered 1 through 3. So we know that in our sample space, and when we're sort of starting to visualize this problem, the only numbers that we can match up between our number cube and our deck of cards is the numbers 1, 2, and 3, because there is no 4, 5, and 6 in our deck. So let's see how that's going to look. So for problems like these, I always like to start off doing a probability tree. So I start by labeling my top. I'm just going to call this game, any label that you like, something to set the game up, right? And then we are rolling our 6-sided number cube first. That number cube is going to have, like it says, 6 sides, 6 different options, so I'm going to draw 6 different branches, labeled 1, 2, 3, 4, 5, and 6. Great, straightforward. And I'm going to label this section right here. This is my first selection. I'm also going to label it number cube. Just for my own sake, so I know where I am in my problem. If I'm showing this diagram to somebody else, I can see right here that this is my number cube and all of my options are right here. So that takes care of our first step of the game. The second step is we are now choosing one card from a deck of 3 cards, each labeled 1 through 3. So let's say we're at number 1. We go 3 options, 1, 2, and 3. And for the sake of consistency, I'm just going to do these very quickly for all 6 options for my first selection. 1, 2, 3. And now keep in mind when you're doing this, you want to make sure that you are keeping everything sort of in the same sort of rows so that I could label this my second selection. And now I can clearly see everything is here, and then the numbers are up here. My first selection consists of all of these, and my second is right here. This is my second selection. Let's call this card draw. Great, so where are my favorable outcomes? You guys have heard me say favorable outcomes a ton of times. We want to make sure we have that definition locked down. So favorable outcomes are our outcomes in our experiment that we want to happen. In this case, it is the probability that the number cube and the card have the same number. So card and cube, same number. Just a little jot so I know what I'm looking for in my problem. So the slow way to do this, but the most consistent way to do this, is to just go through your number tree. Everything is labeled and every possible outcome is here. So we know we have 1 through 6, and the numbers on the cards only go from 1 to 3. So I know I can pair a 1 with a 1, there's one favorable outcome, a 2 to a 2, that's another, and a 3 to a 3 here. And we know that we cannot go beyond these cards. Now, this is something that we haven't really discussed, but we could draw an imaginary line right down the center of our tree. And this is called the reasonability line. I call it the reasonability line because beyond this point, there are no favorable outcomes. We're not going to get to any favorable outcomes. So I can know immediately that from this section on, none of these outcomes are going to give me my probability for my final result. So I can just take these all out. And I know that these 3 are left. 1 to 1, 2 to 2, and 3 to 3. So we all remember how to find our probability, and that was with our equation, number of favorable outcomes, and that is divided by number of total outcomes. Great, so now how do we find the number of total outcomes? So we know the number cube has 6 options, right? This is going to be our total outcomes over here. So we have 6 options for our first selection. Of each of those 6 options, we also have 3 additional options. So for every roll of a 1, we have a chance of drawing a 1, 2, or 3, and likewise for every other roll of the number cube. So we have 6 options and then 3 options for each of those, and that is going to be a total of 18 options. So Right back to the beginning, we are going to do our number of favorable outcomes, which we now know is 3 favorable outcomes, 1, 2, and 3. And that is divided by our number of total outcomes, which is 18. Just going to simplify that, and that is going to give us an answer of 1/6.